Welcome to the Talon Talks podcast from Embry-Riddle Aeronautical University. I'm Alan Caesar. Today's episode is being recorded during October West 2021, the homecoming celebration at the Prescott campus. I'm proud to have Hina Kazmi here. She has been working in aerospace for 25 years, including spacecraft manager at Boeing and as an engineering project manager at NASA. She is now a senior program manager in the Tactical Space Systems Division of Northrop Grumman. She graduated from Embry-Riddle's Prescott campus in 1993 with a bachelor's in aerospace engineering. She has since earned a master's and doctorate in public policy from George Mason University and is an adjunct professor at George Mason. Hina, thank you so much for joining me today.
Thank you very much. Thank you for the opportunity to have this conversation.
You're the first guest I've had in person in a long time. Because of COVID, I've been doing most of these remotely. So it's really nice to meet somebody face to face.
Yes, definitely.
So we're at T-4 questions. Are you buckled in?
I am ready.
All right. So what was your favorite place to spend leisure time when you were a student?
My favorite place that time on Prescott campus was cafeteria. And that was the closest thing to, I guess you can say, a cafe, since there was, we're in away from the town center. So I used to hang out in the cafeteria. There was music. There were friends coming and going. So it was kind of cafe-like environment. So I would park myself with my textbooks and notebooks and study there usually.
Very cool. Well, is there a particular song that takes you back to your Embry-Riddle days whenever you hear it?
Oh, boy. Even Flow by Pearl Jam.
Oh, yeah. Excellent. Grunge era.
Their first album, 10, came out in 91, right in the middle of my schooling. And many of us, my friends, we gravitated to that Pearl Jam music right away. And Eddie Vedder's voice, unique voice. So, that Even Flow song always reminds me of Prescott campus.
That's really cool. What was your go-to late-night meal or snack back at then?
Okay.
While you're listening to Pearl Jam.
While I'm listening to Pearl Jam. So you have to bear with me. I have to explain this a little bit. So I am Pakistani descent, and I've grown up on spicy foods. So when I was away from home here on campus, to make up for that, best thing I could do was this kind of like a side dish kind of in Indian or Pakistani foods, pickles. It's called achar. It could be chutneys, like also you can think of it as pesto and chutney. So it was a green pepper achar. It's a chutney basically. And what I would do is I would always have a jar of that in my cabinet, and I would take a toast, slice of bread, and spread it on it, and just make a little sandwich and eat that. So that was my late night simple snack. Sometimes I would add a little lettuce and make it a little fancier, but anyway, that's what I did.
Oh, that's really cool.
Yeah.
It's a lot of fun.
Not a very common snack, but yes.
No, that's great though. That's really cool. I love spicy food, so I'll have to look that up sometime. So what class or professor had the longest lasting impact on you, either personally or in your career?
I would definitely say it was Dr. Tracy Dorland.
Yeah.
He was also my counselor, and he was really my coach. When I came to Prescott, I was still relatively a kind of new immigrant to U.S. We had moved, my family, we had moved from the Middle East, and it was 5 years really after we had immigrated that I moved out to Prescott campus and joined Embry-Riddle. And so it was kind of first time away from home on my own, and there were tough days and anxiety days, or maybe I wasn't doing so good in class, but I kind of knew I could always go to Dr. Dorland's office, and he would just be this fatherly figure, just give me guidance and coaches, like how to approach some homework problem maybe, or help me kind of make sure that I'm signing up for the right courses the next semester. But he was just always my like a mentor and father figure for me, and his calm demeanor and and another thing was about him was just he had a good sense of humor. He didn't take himself too seriously, even though he knew a lot and everybody respected him, and so I was inspired by him, and always he left a lasting impression, and till this day I'm proud to call him my professor and a friend.
That's great. That's great. Well, you ran into him just today, didn't you?
Yeah, so we came here, and I wanted to just see him. I haven't seen him in so many years now, and luckily I tracked him down, and we just talked before I joined this. Came to see you, and so we'll meet. He said, "Come on over," and so I'm gonna go see him after this and meet his wife and him at their house. Yeah,
that's really cool.
So I'm really happy about that.
Yeah, one of the perks to coming back to campus, I suppose, huh?
Yep, definitely.
So now you recently took a job at Northrop Grumman where you're working on a study contract with NASA for the next lander that will take humans to the moon. Can you fill me in on what this is about?
Oh yeah. Okay. So it is a study as part of the large Artemis program that NASA has. We need to return to the moon and building this lunar habitat, the gateway habitat. And so what NASA is doing is we're in the phase of where it's awarding steady contracts to various industry partners. Northrop is one of them. Blue Origin, SpaceX, Lockheed, all the the well-established names in the industry. They are awarding these study contracts where they want to see what the industry experts can come back with. And I'm very fortunate to be part of the team to work on it. And it's a year-long study. And what NASA hopes to do with this is with these awards to select a catalog of new design that they will then. The next phase would be to award to build these new launch vehicles, transportation vehicles, and lunar landers to just get going with our Artemis program. So it's another step forward in the Artemis program.
Yeah. Well, and so this sounds like it's a competitive program. So you probably want to keep the details hush-hush.
Yes.
But is there anything that you can say about sort of your approach or the areas you're focusing on, or is it like super top secret?
Yeah, I think we're in the initial phase, and yes, it is a competitive. So I couldn't really say much about any of it other than that. Yeah, I think we're all competitors or not. The one thing in the space sector has always been true and absolutely is today, there is a lot of collaboration. While there is competition, because that's just the nature, how it's supposed to be in the private sector, there is also amazingly a lot of collaboration across the private sectors because there are capabilities, that unique capabilities and resources that companies have. And by the way, NASA has across their NASA centers and the facilities that they provide. So it is, I always think of it more collaboration than competition. So we all want to bring our skills and resources, whether they're facilities or simulation capabilities or manufacturing capabilities, and bring them together to because anything in the space world arena, whether we're going to go to Mars or Moon, it requires so many unique skills that becomes a collaboration, really.
Yeah, well, that's great. So now you're also, one of the reasons you're here back on campus is that you're involved in the College of Engineering Philanthropy Council, and you actually saw a number of student presentations yesterday, a number of which involve sending something to the moon. What's it like for you working in that space, like in sort of your day-to-day job, and then seeing students try to go in that same direction?
Oh, I absolutely amazed and impressed. I mean, I can't say enough about how I am impressed by the talent and skills and the knowledge and what I see in our Embry-Riddle students. So yesterday we heard all these presentations, and of course we were just talking about the Artemis program and all the various phases of towards in that progression. And one of the projects we heard that absolutely got me excited was this idea of gas station on the surface of Moon. So as we establish colonies, start to spend more, start building these habitats and spending time on the surface of Moon, we need these, what they call them, gas station, where you can, as you're, on your lunar rover driving around, you need some, where you can stop and maybe, because the harsh environment, you need some place where you can maybe have a shelter. And that's the concept of it. And I thought it was so exciting. And there's another project that I got to see at Daytona campus, the Eagle Camp, part of the Eagle Camp project. So it's a first of the kind selfie camera as a new lunar lander will land, and it can take pictures of the lunar dust and a very close proximity. And so it seems like, our students are right in line. And what I would say is that they're looking kind of 2-3 steps ahead. Okay, well, we'll build those lunar habitats, as I talked about. We'll build the new lunar lander modules. And then what happens? How do we now be able to safely and efficiently build those habitats and work on the surface? And that's what I think these student projects are doing. They're looking ahead and working on those technologies. And I will not be at all surprised that they will come out in the industry and they will help mature these technology when they go out and work in the private, government or private sector.
Yeah. Well, so that kind of, with this talk about lunar habitats and so on, there's been a fair amount of civilian travel into space recently with, Jeff Bezos, Elon Musk, and then the Inspiration 4 launch, which sent actual 4 civilians into space, 2 of which were Embry-Riddle alumni. So it feels like the thing that we've been promised for like 50 to 60 years is finally starting to happen. And you're working on the bleeding edge of it. What kinds of things do you wonder or sort of worry about as this becomes a reality?
As a space geek that I am, and I
think we all are
worry.
A little bit.
Yes, we all are, and good for us. I don't know if I would say things that I worry about because it has been in the making, like you said. And frankly, by the way, when we say we've been waiting for this moment now that we're witnessing in our lifetime, it's kind of the turn of into the new space age, really, right? So with the civilian astronauts, and it has been in the making. So it does take that much time. It's a capability that we had to work towards. So space station was our kind of launching pad per se to these bigger objectives. Now we're finally getting to where average people can now have a chance to experience space travel, and it's no longer a science fiction conversation. We can actually, in our lifetime, seeing that happen. And what I would say is, rather than say that I'm worried about it, what I feel like there's an opportunity here for all of us, whether we are directly working in this technology field, in the aerospace industry or not, of as we extend space travel to just, civilian population, how do we kind of remind ourselves to be that one kind of Earth people? I know it sounds idealistic, but be, instead of creating a kind of competition between nations, this is an opportunity for us to just look at ourselves as from this planet Earth, as Carl Sagan said, that one pale blue dot. We are from that pale blue dot, and now that we're expanding our wings beyond our Earth's atmosphere, we could work as one people of the planet Earth instead of different nationalities, and we know we can do that because we have that experience and we have proven that we can collaborate across nations through ISS. So International Space Station is the finest example I can think of really internationally coming together, just one human race and working together. And the toughest of political differences between Russia and U.S., our astronauts were working together in the space station. So there's absolutely, and not just those two countries, internationally, Asia, Europe, across the board, in South America, we've had astronauts from all parts of the world working together as, just astronauts. And I think that's what I hope we keep our focus on, exploring the space for the peaceful purposes of our extending just kind of human race, and utilizing those resources in the outer space that we can, the economic potentials that are out there, but doing it as people of the earth rather than, having that national security type competition. This is the only thing I say that we have an opportunity here to think about all of us across nations.
Right. Yeah, I mean, I sort of the ISS is like the realization of like the Star Trek ideal of like this multi-cultural, multiracial, multi-species, all in one place.
Yeah, I really hope we keep that in the forefront rather than as an ideology in the background. That's really maybe what I'm getting at, that we keep our eyes on that purpose.
Yeah, well, so you're pretty hopeful then that it's possible to have sort of an international peaceful use of space.
I am hopeful. Some may think I'm too idealistic, but I think we have an opportunity. And as putting, like I said, putting it in the forefront, okay, why don't we collaborate together? Because if you think about it, Alan, what I just explained, building these new lunar habitats, going to Mars is going to require collaboration rather than competition between firms and expertise, right? Similarly, going out to explore the space, and we're, after the moon and Mars, there's still a lot of space. There's deep space travel. We can only do that collaboratively, coming together, just like we worked on ISS and gained that in space, experience collaboratively across nations. So that's the best chance of our success of really having a deep space exploration capability coming in the next generations. Yeah.
Well, so you talk about competition, and you worked in space-related projects in both the public and the private sectors. What do you think of the particular roles these days of public versus private, and is one better suited for certain types of projects than the other?
Private versus public is far more blended today than it was, let's say, in our first space age, right? The Apollo era. It was really driven by government and government funding and government objectives, and government was dictating, what space programs were going to be, developed. We have, 60 years later, and rightfully, we've come to a point what we call the new space age. So these companies are enabling civilians to go in space and do space travel, and rather than be, let's say, NASA-trained astronauts. While that's happening, it is a commercial focus. So it is a commercialization. We are in very early stages of that era, right? At the turning. So what I would say is that we're not separate from government. We are reliant on government, not only their government funding, but also government objectives. So the Artemis program, right? So that came in place. Now that is a government-funded objective. And so the companies are supporting and getting funded to set our lunar habitat, and then have it as a launching pad to then establish our colonies on Mars. So government and private sectors are really our partners. So the roles have changed. It's not that government is dictating what needs to happen. They have goals and objectives, and here's a private sector partnering with them and advancing those goals. And so that's how I see it. So it's great now, and what I suspect in the next 20 to 30 years, we really are going to see what you may think of truly privatization of space travel. But we're at the early stages of it, where government is still very much part of the equation.
Okay.
If that makes sense. Yeah.
Yeah. You're an engineer. And engineering to me feels like a very tangible, kind of grounded, practical type of study. You're usually trying to solve like sort of very specific problems. My perception is that public policy is very different. Like you're still trying to solve problems, but they're more conceptual, if that's the right word. Like the answers are less obvious, the feedback loop is longer, it's harder to see if things work. There are a lot of externalities you can't control. How did you get into public policy? Why did that appeal to you? It seems like such a completely different realm.
Yeah, they do. At the face of it, they do seem very different. One social science, and one is more towards hard science, right? Mm-hmm. And so I think professionally, by education, I gravitated towards math and engineering, and that was my skill set. And aerospace was definitely something that was my passion, and I always knew I was going to do that. public policy is a kind of, the best way I can describe it, public policy is kind of throughout, is woven throughout everything we do, whether we are engineers, whether we're doctors, whether we're, pilots or mechanics or technicians or any profession, any trade you may be in. Public policy is really kind of woven into our day-to-day things. You look around, we're here in this office, in this room, and doing this podcast. If you look around, there are a lot of things here. The way these lightings are, the way the sprinkler system is set up. Mm-hmm. These are all out of policy and regulations. Policy drives the regulations and regulations. So it's all part of us. It's all around us, and it's so part of us that we don't notice it. But what interested me in public policy is that. This is really where the decisions come from, how that impact our day-to-day lives, and what government does, what government programs, what priorities government has. Those are all policy discussions, and they impact us whether in our professional life, in our personal lives. Our kids go to school, what curriculum, what is the priority of what they're studying. That's all based out of public policy discussions and those debates. So that was always my interest. As a social science was always my interest. So yes, I knew always that I was going to go in that route, and using engineering and the technical training that I've gotten actually has helped me. It helped me in my public policy education, because policy is driven by, hopefully, you would always hope, based on some data, some analytical context to the discussions that we have. There's some trend analysis. Based on that, this is the policies we should make in XYZ area. So there's a lot of technical content and calculation behind many policies that then eventually become regulations. So there's a connection there, technical connection, you can say. That's kind of how I brought the two together, I guess, two disciplines in my career, in my professional life.
That's really cool. Now, I feel like I would be remiss if I didn't mention your work on SOFIA, the Stratospheric Observatory for Infrared Astronomy. You were a project manager for that. What was your specific role there? And tell me what you did and how you enjoyed that work and that project. That's a pretty special thing that you were doing.
So SOFIA was absolutely the highlight of my career. It was a unique opportunity. I had that opportunity to lead as a program manager. So I was director of program management on the SOFIA program. My role was to help maintain the SOFIA mission operations. Mm-hmm. So the operations side of SOFIA. SOFIA is an infrared observatory. It's a telescope that is mounted on a modified 747 SP plane. It's an old plane that NASA acquired. And it's a collaboration between German aerospace and NASA. And it is one of a kind, unique observatory, airborne observatory. Mm-hmm. We fly at 42,000 feet and 42 and above, and we take infrared images and it's infrared astronomy. I felt fortunate to work on this unique mission, and my job was to make sure the operation, the plane flies, and all the, there's a lot of ground equipment. There are a lot of science instruments aboard besides the telescope on mm-hmm. the plane that capture the data, observatory data, and then translate that into these beautiful images that we see later on. So I just managed a program team there, and it was like a highlight of my career. Like I said, I was fortunate enough to fly with SOFIA. As a manager, I was able to fly a few times, and so we had a whole full mission operations team. So I was called it. SOFIA had a airborne mission operation control room, and it's another wonderful example of international partnership with our German partners.
That's really cool, and I was definitely super excited when one of the perks of working at Embry-Riddle is that SOFIA came and landed at the Daytona Beach campus when I was
right.
Yeah, and so there were lots of their shuttle buses that went out there, lots of students, faculty. I went on board. It was really exciting and such a cool piece of equipment to see and to walk through. So really great to meet somebody who's super involved in it.
Oh, thank you. Yeah, and SOFIA has a large international community involvement, right? Scientific community who has used SOFIA for a lot of their astronomical observations and studies. So yes, it's a prominent observatory, and I'm really proud to be part of it. So thank you.
Great. Well, so we're solidly in orbit now. So I have 2 more questions for you before we go to break. One, what do you think? What skills do you think are critical to succeeding in your line of work?
In my line of work, there is kind of 2-step process. One is kind of starting off after college, as you're starting off in your career in the aerospace field, is kind of honing in on some key technical aspect. So personally, I started out in design and development and qualification of space electronics, power processing units. Okay. Now, that sounds very specific, but what that helped me learn starting out my career was kind of the unique requirements that you need to understand to build hardware, whether it's launch vehicle, whether it's lunar landers, or whether it's satellites of this space environment. And because once you launch something, you can go fix it. So it needs a lot of redundancy. It has the harsh space environment, the harsh launch loads. So you learn those kind of key, by designing some space hardware, you get a working understanding of those key space hardware requirements. So that's one step. But then next step, probably more important, is having that system level understanding of how to build these satellites. So it's just large space system, whether it's launch vehicles, satellites, or habitats or gateways. Having a system-wide understanding of all the subsystems that come together to give you this one complete system, that is something I think is important skill set that I was able to pick up. So what I call it, and I work towards being a program manager. I just like managing these technical programs. That was something I got into, and I call my skills as a mile wide, inch deep, meaning understanding those larger system and subsystem, how they come together to make one system, whether it's a satellite or launch vehicle, etc. And just kind of understanding the risks in when you are building space hardware and anticipating some of those risks and planning for this. That's a very critical skill set as a program manager in space when you're working on space hardware. So that is something you just over time you have to develop, I think. So I'm not sure if I answered your question.
No, I think you got it. I think you got it. And the mile wide, inch deep sort of speaks to the scope of it, right? Yeah. So if you could go back in time and give your younger self one piece of advice, what would it be?
Okay, it's a non-space advice, but it would be, I would go back and buy my first house sooner than I did. I know, it's not very, I think just kind of investing. When we're young and we're starting our career, we're not really thinking often along those lines, but I say, wow, instead of paying high rents in the Silicon Valley where I started my aerospace career, if I just bought a small place, well, I would have been 30 years later, it would be great. So my advice to myself would have been, invest in real estate as early as soon as I started my professional career, started, making a living.
Right. Yeah, buying a house in Silicon Valley in 1994 would have been fantastic, right?
Exactly. So that's advice I would give myself if I could go back.
That's so good. All right, we'll be right back with the Splashdown. Hey, Talon Talks listeners and fans. Giving Tuesday falls on the first Tuesday after Thanksgiving, and it's the unofficial start of the season of giving. It's also an international celebration of generosity, so I hope you'll celebrate with me this year. I'm inviting you, our alumni, my fellow employees, fans of Embry-Riddle and fans of this show, to be part of the movement that's funding student success here. In the past, we've raised as much as $40,000 in a single day with our Giving Tuesday campaign. This year, our goal is to show just how many supporters will come together on that special day, and I want you to help us reach our 200 donor goal. Personally, my gifts to Embry-Riddle support the women's soccer team and a specific flight scholarship that's important to me, but my Giving Tuesday donation this year will go to the students at WIKD Radio. It was their idea to launch this podcast, and they provided so much of the technical support and audio editing to get us started. And if you have any personal history with Embry-Riddle, I'm sure there's a student club or a college or a scholarship that is particularly close to your heart. So your gift today to whatever area of focus matters to you will enable our students to soar to new heights. I want you to visit givingto.erau.edu/GT to see what it's all about. And though Giving Tuesday is just one day, November 30th, you can give early and be counted. I'd personally be super grateful if you visited the page and not only made a gift today, but also helped us spread the word. Email your friends, post on social media, send a group message to some of your old college buddies, send a carrier pigeon, whatever it is that you do. I am grateful for you. Visit givingto.erau.edu/GT and participate in Giving Tuesday with your donation today. Thank you so much. All right, Hina, are you ready for the splashdown?
I am ready.
Okay.
Back home.
What was the one experience that got your heart hooked on aerospace?
I can definitely say that one moment, my early part of my career, I was I was assigned as called vehicle engineer.
Mm-hmm.
This is the satellite manufacturing floor, so we call it high bay typically. And I was just this young engineer, and basically my job was to be a floor engineer. So if any technical issues came up, they would call me, and I would have to disposition to fix whatever the issue was at the time, or as you're building the hardware, putting it together as one satellite. And I remember very well that I was inside this hollow kind of cylinder. So that's where the propulsion tanks will eventually go, and then you build out your satellite. So it was like a structural shell yet. We hadn't installed all the components. I was in there doing some inspections. And I realized that, oh my God, I was just literally touching the structural surface for some inspection. And I say, this satellite will be launched in a geosynchronous orbit, but 22-some thousand miles above our surface, and my DNA is going with it. And that was just a fascinating idea that I guess it was obvious, but it didn't, just at that moment it occurred to me that, wow, I'm not going in space, but my DNA, the part of me is going there. And so I think that was my, I was hooked on it. And I also realized those are some of the part of aspirations that many of my colleagues had working on satellites, that we can't be in space ourselves, but there's a part of us is going there. We're helping to kind of build these satellites, and it's just a piece of us goes there, and it's very inspirational.
That's great. What's a book that's been important or influential for you?
Oh, Moby Dick.
Yeah?
Oh, absolutely. Moby Dick has been, it's kind of been a very big inspirational book for me, just in many aspects. And one of the interesting about Moby Dick is that, it's a very technical book. It's like a technical specification. I remember as I'm reading it, and I read it after I had graduated from Embry-Riddle and I started working, so I could kind of appreciate some of the technical nuances in it, because the way he dives into very details of anatomy of the whale. He really talks about, so if hopefully I'm assuming your listeners know about Moby Dick as a book. But he really has chapters in detail talking about the details of anatomy of the whale. He gets into technical specifications almost about the whaling process itself. That's what he did, I guess, as a living. And he describes these whale lines. So these are like the cords that they're tied as harpoons that they would catch the whales and then rope them back. And he talks about how to get the oil from the whale. I mean, it's a very engineering technical book. And what the beauty of that book, among many beauties of that book, is how he connects the technicalities that he talks about of the whaling boat and ship and everything and the process to kind of philosophical aspects of human beings and day to day. He just interwoves this so beautifully. And I have this one kind of quote I wanted to if you don't mind, if I can read to you, to give you just kind of sense of where, how he does that, right? So he's, in this one chapter, he's describing the whaling line. Like I said, it's this it's a very thick cord, obviously, to put rope in a whale. So it's
right.
And he describes how that rope is built, literally. He goes into the details of it. And then he, pretty much at the tail end of the chapter, then he goes into, and this is what I'll read, quote from his book, is, all men live enveloped in whale lines. All are born with halters around their necks. But it is only when caught in the swift, sudden turn of death that mortals realize the silent, subtle, ever-present perils of life. So he goes from describing this rope, whale line rope, all the way to really brings it into our, just a human condition, I think. So so that's a book that always inspires me.
That's great. I didn't I didn't realize that it was so technical and that it used the technicality to sort of draw in the human condition, sort of the darkness of our own existence, right?
Exactly.
I just kind of knew that. I've never read it myself. I just sort of absorbed from culture that it revolves around Captain Ahab's obsession, there's clearly more to it than I realized.
And actually, it's interesting if you really read the literary reviews on the book, and there's so much have been written on this book, is the Herman Melville's own obsession with whaling and that profession. So he's really used that, I would call, engineering technical skill set to really connect, so he really relates it that way. So the way he describes these things, it's his own obsession that comes through, whether it's for that profession or etc. So
that's really cool. All right. In a completely different, lowbrow direction, who's your favorite cartoon character?
So my favorite cartoon character is Winnie the Pooh.
Okay.
It's absolutely. Now, I love Winnie the Pooh because I have always aspired to be like Winnie the Pooh, but I'm not. I am more like the rabbit. So I appreciate the rabbit, but I want to be Winnie the Pooh. And the reason is because Winnie the Pooh really is that Zen-like wisdom, right? That everything is going to be fine. And he never takes himself seriously or really others come to him with problems, but he just so calmly can help them and put things in perspective, that everything is going to be all right, and it's all about just going and eating honey. And but I really do. I think I don't know. It's a character that I just aspire to be, I think. But like I said, I relate to Rabbit, where Rabbit is just always struggling and trying so hard to keep everything in order and have control. And just when he thinks he has control, he realizes he has no control. And that's kind of, I feel like in general, most of us are. We're trying to keep things in order, trying to have control over whatever we're doing. But we realize oftentimes we have really little, so it's better off being like Pooh than Rabbit, in my opinion.
Yeah, we really made a turn from Herman Melville and that dark obsession to the innocence of Winnie the Pooh.
Innocent, the childlike of Winnie the Pooh.
That's so good. All right, so you can go to the Olympics and compete in any sport. What do you choose? Let's see if we can take another 180 here.
Swimming.
Swimming, okay.
Oh yeah, I learned swimming really late in life. I was in my 30s when I first learned swimming, and I got hooked on it right away. And swimming is one kind of physical activity that you just you truly can be disconnected. When you're in water swimming, you don't hear sounds around you. You're not seeing anything. You just focus and you swimming. And you really can disconnect. And in our day and age now, with all the devices around us that we're connected to all the time, I think swimming is one place you can just completely be, disconnected from everything around you, and to kind of bring it home, with the aerospace context, it's like that feeling of, I must feel like how you're floating in space, in water, or flying like a bird. It gives me that feeling. It's just very, very wonderful feeling to swim. So that's really cool. I would absolutely do that if I could.
Yeah. Well, I think swimming and scuba diving is part of the astronaut training program, right?
Absolutely, it is.
I've heard that that experience is so similar to being weightless in space, is that the astronauts astronauts are actually watching for like the air bubbles to float up past them when they're actually out doing spacewalks, because it's so familiar to that sort of.
Yeah, no, you're absolutely right. That's so I guess I can relate to that. That's my way of getting space travel.
There you go. All right, so if you could live for a week as any person in history, who would it be?
Oh, let's see. I'm going to say Mark Twain.
Okay, I got another deep literature. Here we go.
Yeah, I have been a Mark Twain fan, ever since I read his books. And I guess I want to be in his head, or I could be, because he was multi-talented, first of all, right? Mm-hmm. So he was a journalist. He was a patent attorney. He was a traveler. Novelist, humorist, and very satiric.
Yeah, satirical.
Satirical writings, and I absolutely, and that sense of humor that he had. And at the same time, I felt like, he had a lot of tragedies in his life. He lost his children, 3 out of 4, before, his own, in his lifetime. And I think all of that he expressed it in this satirical humor that he did, that we read and enjoy. But yet there was this kernel of kind of the harsh realities in the Huckleberry Finn and Tom Sawyer. So there's that humor, but then there's this reality in the background that he's reflecting on of his time. So. And I don't know, I felt like he was just multi-talented. You can't put him in one box, and it was just a great novelist, American novelist. So I would love to just be in his company or be him, just as, what a mind, I would say.
Well, that's great. Well, thanks so much, Hina, for taking time out of your trip to Prescott and joining me for the Talon Talks podcast.
This was so much fun. Thank you so much, Alan. I appreciate you asking me to join you in this conversation. Thank you.
It's truly an honor to have you. This episode of Talon Talks is a production of the Embry-Riddle Office of Philanthropy and Alumni Engagement and the students at Wicked Radio. We're coming at you from, I'm borrowing a colleague's office at Embry-Riddle's Prescott campus for today's recording. This episode was recorded by me and edited by the students at Wicked. Michelle Day is our program manager. Edmund Dodarte is Executive Director of Alumni Engagement, and Tony Brown is Executive Director of Communications. Please send us your thoughts about our show. Visit alumni.erau.edu/podcast and click the feedback link. I read all your messages. Thanks for downloading us. We'll see you next time.